Welcome to where time falls quiet.
Antarctica on a 1513 map. Who surveyed it first? Take a moment to subscribe, so this place of calm is always here for you. What if the story of human civilization is written backwards? What if the monuments we call ancient are not the beginning of something, but the fading echo of an ending? What if everything we've been taught about the first cities, the first laws, the first writing, is not the dawn of human achievement, but twilight? Hold that thought. Because what you're about to hear isn't another retelling of the history you learned in school. This isn't a casual stroll through the familiar narrative of humanity crawling out of caves and stumbling toward agriculture. This is something else entirely. This is about the evidence that refuses to fit the timeline. The artifacts that shouldn't exist. The knowledge that appeared, fully formed, as if handed down rather than discovered. And most unsettling of all, this is about the silence in the historical record where something vast should be. A silence so profound that entire civilizations could have drowned in it. The accepted story goes like this. Around 5,000 years ago, give or take a few centuries, humanity suddenly figured out how to live in cities. The Sumerians in Mesopotamia, we're told, were the first. They expected to find humanity learning how to write, how to calculate, how to organize society. Instead, they found something that should have been impossible. They found sophistication. The mathematical system they used, based on the number 60, was so advanced that we still use it today to measure time and angles. There was no prototype phase, no evolutionary development. The civilization emerged, as one historian uncomfortably noted, as if it had been delivered whole. And it wasn't just the Sumerians. Look at Egypt. The pyramids at Giza, built supposedly during the 4th dynasty around 4,500 years ago, represent engineering at a level that wouldn't be matched for millennia. The Great Pyramid's alignment to true north is accurate to within 1/15th of a degree. The ratio of its perimeter to its height encodes pi to remarkable precision. The weight of its blocks, the angles of its passages, the astronomical correspondences embedded in its design, all of this suggests not just competence, but mastery. Yet, according to conventional chronology, this monument was built by people who, just centuries before, were supposedly figuring out basic agriculture. The same pattern repeats across continents. In the Indus Valley, cities like Mohenjo-Daro appear suddenly with sophisticated urban planning, standardized brick sizes, and advanced drainage systems. In Mesoamerica, the Olmec civilization emerges with astronomical knowledge and a calendar system of bewildering complexity. In Peru, the earliest known construction at sites like Corral shows architectural sophistication that suggests, once again, that the builders weren't beginners. They were implementing knowledge they already possessed. So where did this knowledge come from? The conventional answer is independent invention. Different cultures, separated by oceans and millennia, somehow arrived at similar solutions to similar problems. It's possible, but it's also convenient, because it allows us to avoid asking a more uncomfortable question. What if they didn't invent it? What if they inherited it? Consider this. In ancient texts from multiple cultures, there are references to a time before. The Sumerians themselves wrote of antediluvian kings who ruled before the Great Flood, rulers with impossibly long reigns that stretched the boundaries of credibility. The Egyptians referenced the Zep Tepi, the first time, an age of gods who walked the earth before pharaohs. Hindu texts describe cycles of civilization rising and falling over vast epochs. Plato wrote of Atlantis, a powerful maritime civilization that sank beneath the waves 9,000 years before his own time. For centuries, scholars dismissed these accounts as mythology, as metaphor, as the poetic imaginings of prescientific minds. But what if the ancients weren't imagining? What if they were remembering? What if the flood myths found in over 200 cultures worldwide aren't separate inventions, but separate mema? Eyes of the same event? What if the sophisticated knowledge that appears so suddenly in the archaeological record wasn't created by these early civilizations, but salvaged from an earlier one? Around 11,700 years ago, something catastrophic happened to Earth's climate. The last ice age ended not gradually, but abruptly. Global temperatures spiked. Ice sheets covering North America and Europe collapsed. Sea levels rose by 400 feet over the course of several millennia, drowning coastlines and flooding river valleys across every continent. This wasn't a gentle transition. It was a planetary convulsion that would have rendered massive areas of previously habitable land uninhabitable. Any civilization that existed before this deluge, any cities built on the coastal plains that are now submerged beneath 300 feet of seawater, would have been erased from the terrestrial record. And here's what makes this idea more than speculation. In recent decades, underwater archaeology has begun to reveal structures on continental shelves, megalithic formations off the coast of Japan, geometric patterns beneath the waters near India, anomalies that suggest human construction in places that have been underwater for 10,000 years or more. These discoveries are controversial. They challenge fundamental assumptions. But they exist. They're measurable. They're there. So imagine this scenario. 20,000 years ago, while ice sheets covered much of the northern hemisphere, sea levels were dramatically lower than today. The coastlines were different. What is now a shallow ocean was once dry land. And on that land, with resources and space and a stable climate in certain regions, what if a civilization arose? Not everywhere, not in the frozen north, but in the temperate zones, the accessible coasts, the fertile river deltas that no longer exist above water. What if they built cities? What if they developed mathematics, astronomy, agriculture, navigation? What if they thrived for thousands of years while the ice slowly melted? And then, what if the warming accelerated? What if the ice sheets collapsed catastrophically? What if their coastal cities, their ports, their centers of learning and trade were inundated so rapidly that evacuation became the only option? What if the survivors scattered to higher ground, carrying with them fragments of what they knew, trying desperately to preserve the knowledge that had taken millennia to accumulate? What if the Sumerians, the Egyptians, the Harappans, the Olmec weren't starting from zero, but from broken pieces? This is the question that haunts the evidence. This is the whisper before the flood. And once you hear it, you can't unhear it. Because suddenly, the anomalies make sense. The sudden appearance of sophisticated knowledge makes sense. The global distribution of similar myths makes sense. The architectural achievements that seem impossible for their supposed time period make sense, if we're willing to accept that the time period might be wrong. The conventional timeline of civilization says we are the pinnacle, the unprecedented culmination of a linear march from primitive to advanced. But what if we're not the first to believe that? What if every cycle of civilization thinks it's the first? What if the greatest achievement of those who came before wasn't what they built, but what they tried to save when the waters rose? And what if we're living with the inheritance of their desperation, reading their last messages encoded in monuments and myths, without realizing we're looking at blueprints for survival? The flood didn't just drown cities, it drowned context, it drowned the story. And now, thousands of years later, We're excavating fragments, finding precision where there should be crudeness, finding knowledge where there should be ignorance. Finding a pattern that suggests restoration, not invention. The whisper grows louder with every anomaly, every submerged structure, every too perfect alignment. Something existed before, and it's still speaking to us through the only language that survives drowning: stone. There's a map in the Topkapi Palace in Istanbul that shouldn't exist. Not shouldn't as in it's unlikely, but shouldn't as in the knowledge required to create it should have been impossible in the year it was drawn. The Piri Reis map, created in 1513 by an Ottoman admiral and cartographer, shows the Atlantic coastlines of Europe, Africa, and South America with remarkable accuracy for its time. But that's not the disturbing part. The disturbing part is what it shows at the bottom of the parchment, where Antarctica should be, except Antarctica wasn't officially discovered until 1820, and the coastline depicted isn't the ice-covered landmass we know today. It's the coast as it would appear without ice. Piri Reis himself wrote notes in the margins of his map, explaining that he compiled it from older source maps, some dating back to the time of Alexander the Great, others even more ancient. He wasn't claiming to have surveyed these coastlines himself. He was claiming to have copied them from charts that already existed, charts that depicted a world his contemporaries didn't know existed. For centuries, scholars dismissed this as fantasy, as artistic license, as anything but what it appeared to be. Evidence of ancient maritime exploration at a level supposedly impossible for the era. But then something changed. In 1966, Professor Charles Hapgood, a historian of views, brought the map to the attention of the United States Air Force Cartographic Division. He wanted expert analysis. What he got was confirmation that should have rewritten history textbooks. The Air Force cartographers concluded that the southern portion of the map accurately depicted the Queen Maud Land coast of Antarctica, a coastline that has been buried under mile-thick ice for at least 6,000 years. To map that coastline accurately would require either satellite imagery or direct observation before the ice formed. Neither should have been possible in 1513 or in the time of Alexander or in any era that conventional history acknowledges. The Piri Reis map isn't alone. There's the Oronteus Finaeus map of 1531, which shows the entire Antarctic continent with rivers, mountains, and coastal features, all depicted in a continent that should have been invisible beneath ice. There's the Philippe Buache map of 1737, which shows Antarctica divided into two major landmasses by a waterway, a detail that wasn't confirmed until 1958, when seismic surveys revealed that beneath the ice, Antarctica is indeed two landmasses connected by a frozen bridge. Buache's map claimed to be based on even older sources he couldn't name or explain. And then there are the portolan charts, medieval maps of the Mediterranean and surrounding regions that display accuracy comparable to modern satellite surveys. These charts, appearing suddenly in the 13th and 14th centuries, show coastlines, harbours, and distances with precision that seems impossible for the maritime technology of the time. They use a projection system that suggests spherical geometry and an understanding of longitude that European navigators supposedly didn't develop until the 18th century. The charts themselves offer no explanation for their accuracy. They simply exist, passed down from earlier sources, copied and recopied until the originals were lost. The conventional explanation is that these maps were lucky guesses, artistic interpretations, or misidentified land masses. The Antarctica on the Piri Reis map, some scholars argue, is actually South America distorted. The accuracy is coincidence. The ancient sources Piri Reis cited were exaggerations or misunderstandings. But that explanation requires ignoring the mathematical precision. It requires ignoring the consistent testimony of the mapmakers themselves, who repeatedly claimed they were copying from older charts. And it requires ignoring the geographic details that couldn't have been confirmed until the 20th century. Consider the problem of longitude. To accurately map coastlines on a global scale, you need to determine not just latitude, which can be calculated by observing the sun and stars, but also longitude, which requires either precise timekeeping or sophisticated astronomical observations. The European powers didn't solve the longitude problem until the 1700s, when chronometers accurate enough for maritime navigation were finally developed. Yet, the portolan charts of the 1300s display longitudinal accuracy that shouldn't have been achievable. This suggests that whoever created the original source maps had already solved the problem, centuries or millennia before it was supposedly invented. Now imagine you're a cartographer in the 15th century, and you're shown a collection of ancient maps. These maps depict coastlines you've never seen, continents you didn't know existed, and details that shouldn't be visible. You don't understand the projection system. You don't know how the original surveyors calculated distances with such precision. You don't know why some of the coastlines don't match what your contemporaries report. But the maps are there. They're detailed, they're consistent, so you copy them, you compile them, you preserve them, even though you can't explain them. This is the testimony of Piri Reis and others like him. They weren't claiming to be explorers. They were claiming to be archivists, preserving geographic knowledge from sources they couldn't identify or verify. And the knowledge they preserved depicts a world that only makes sense if it was surveyed before the end of the last ice age, before the coastlines changed, before the ice sheets covered Antarctica. The implications are staggering. To create accurate maps of Antarctica without ice would require maritime expeditions during a period when that continent was accessible, which means before approximately 6,000 years ago at the latest, and possibly as far back as 13,000 years ago. It would require a civilization with advanced navigation, the ability to calculate latitude and longitude, and the motivation to conduct extensive surveys of the planet's coastlines. It would require, in other words, exactly the kind of sophisticated maritime culture that the conventional timeline insists didn't exist. And it's not just Antarctica. The Piri Reis map also shows the Andes Mountains in South America, rendered with reasonable accuracy, and the Amazon River flowing from those mountains. At the time the map was drawn, European knowledge of South American geography was minimal. The interior was unexplored. Yet the map includes details that suggest the source material was based on extensive exploration of the continent. Where did that knowledge come from? Who surveyed the Amazon basin and rendered it accurately enough that a 16th century Ottoman admiral could copy it onto parchment? The same questions apply to other ancient cartographic anomalies. The Zeno map of 1380 shows the North Atlantic with details of Iceland, Greenland, and possibly even parts of North America. The map is controversial, dismissed by some as a forgery or a misinterpretation, but it depicts geographic features in the Arctic that weren't officially explored until centuries later. Again, the mapmaker claimed to be working from older sources. Again, the accuracy is difficult to explain. What we're looking at is a pattern. Maps appearing throughout history that depict geographic knowledge they shouldn't contain, all claiming to be copied from even more ancient sources. And those sources, whoever created them, had access to information that suggests global maritime exploration at a level that shouldn't have been possible according to the accepted timeline. This isn't about a single anomaly. This is about a system of knowledge that existed, was copied, was preserved, and was eventually lost except for these fragments. The maps are evidence of memory, cartographic memory. A civilization that explored the world, surveyed its coasts, calculated its dimensions, and recorded its findings, left those records behind when it vanished. The survivors, or the cultures that inherited the fragments, preserved what they could. They didn't understand the full scope of what they were copying. They couldn't verify the distant lands depicted. They couldn't replicate the precision. But they preserved the knowledge anyway because it was valuable, because it was ancient, because it represented something important that had been lost. And now we have these maps, sitting in museums and libraries, depicting coastlines from a world that no longer exists above water. They're witnesses to a time before the flood, before the ice sheets melted, before the sea levels rose and drowned the lowlands. They're blueprints of a planet that was different, drawn by hands that knew that planet intimately. The question isn't whether these maps are accurate. The question is how they could be accurate given everything we think we know about the past. And the only answer that fits the evidence is the one that rewrites the timeline. Someone was here before. Someone was mapping the world. And when the waters rose, the maps survived, even as the mapmakers did not. There's a clay tablet in the Yale Babylonian collection that's been sitting there for over a century, catalogued as Plimpton 322. It's small, about the size of a postcard, and it's covered with rows of numbers written in cuneiform. For decades, scholars assumed it was an accounting document, perhaps a record of commercial transactions or tax calculations. It wasn't until 1945 that mathematicians took a closer look and realized what they were seeing. The tablet contains 15 rows of Pythagorean triples, number sets that satisfy the equation where the square of one number plus the square of another equals the square of a third. But here's what makes this tablet extraordinary. It was created around 1800 years before Christ, more than 1,000 years before Pythagoras was born. The Sumerians and their Babylonian successors didn't just stumble onto these mathematical relationships. They systematically calculated them using a sophisticated understanding of number theory that wouldn't be formally developed in Europe until the Renaissance. The tablet isn't a list of discovered triples. It's a generated table created using algorithms that demonstrate an understanding of abstract mathematics far beyond what should have been possible for a civilization that was supposedly still figuring out basic arithmetic. The numbers aren't random. They're ordered, calculated, and precise. Someone knew exactly what they were doing, and they knew it 3,800 years ago. But the Pythagorean triples are just the beginning. The Sumerian mathematical system itself is an anomaly that demands explanation. They used a base 60 system, sexagesimal notation, instead of the base 10 system that seems natural to us because we have 10 fingers. Why 60? Because 60 is a highly composite number, divisible by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This makes calculations involving fractions remarkably elegant. Division becomes simpler. Astronomical calculations become more manageable. It's not the obvious choice, it's the sophisticated choice, the kind of choice that suggests long experience with complex computation. And we still use it. Every time you check the clock, you're using Sumerian mathematics. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. These aren't arbitrary choices, they're inheritances from a mathematical system developed thousands of years ago by people who, according to the standard narrative, had just invented writing. The sophistication embedded in that system suggests it wasn't invented in Sumer. It was brought there, fully formed, by someone who already understood its advantages. Now shift your attention to Egypt, to the astronomical alignments built into the pyramids and temples. The Great Pyramid is aligned to true north with an accuracy of 3/60ths of a single degree. To achieve this alignment requires precise observation of stellar movements, sophisticated understanding of Earth's rotation, and careful calculation. The shaft inside the pyramid points to specific stars, Sirius and the constellation Orion, with geometric precision that encodes mathematical relationships between pi and phi, the golden ratio. These aren't approximations, they're deliberate embeddings of mathematical constants into physical architecture. The Egyptian calendar was also remarkably sophisticated, based on a year of 365 days, divided into 12 months of 30 days each, plus 5 additional days. They tracked the heliacal rising of Sirius, the moment when the star first becomes visible on the horizon before sunrise, using it to predict the annual flooding of the Nile. This required sustained astronomical observation over centuries, along with mathematical calculations to account for the slight drift between the solar year and their calendar. The precision of their system suggests they inherited a framework for astronomical timekeeping and refined it, rather than developing it from scratch. And then there are the Maya. Their calendrical system is so complex that it makes the Gregorian calendar look simplistic by comparison. They used multiple interlocking cycles, the Tzolkin, a sacred calendar of 260 days, the Hab, a solar calendar of 365 days, and the long count, which tracked time in units called baktuns, each consisting of 144,000 days. The mathematics required to calculate the interactions between these cycles demanded an understanding of least common multiples, modular arithmetic, and astronomical periods that modern mathematicians find impressive. The Maya calculated the solar year as 365.2420 days. The actual solar year is 365.2422 days. Their margin of error was 0.0002 days per year. They calculated the lunar month as 29.53059 days. The actual lunar month is 29.53058 days. These weren't rough estimates, these were the results of centuries of precise observation and sophisticated mathematical analysis. But according to the archaeological record, the Maya appeared with this system already in place. There's no evidence of gradual development, no earlier versions with cruder calculations. The mathematics arrived complete. Here's where it gets unsettling. These three civilizations, separated by oceans and millennia, all used mathematical systems based on 60 and 360. The Sumerians used base 60. The Egyptians divided the circle into 360 degrees and used astronomical calculations rooted in 60-based subdivisions. The Maya used cycles of 360 days and incorporated subdivisions that align with sexagesimal mathematics. This isn't coincidence. This is a pattern. And patterns suggest connection, inheritance, or shared source. The number 360 itself is suspicious. It's not derived from natural observation alone. Yes, there are approximately 365 days in a year. But why round it to 360? Because 360 is divisible by nearly everything. 2, 3, 4, 5, 6, 8, 9, 10, 12, 15, 18, 20, 24, 30, 36, 40, 45, 60, 72, 90, 120, and 180. It's a mathematician's number chosen for its utility in calculation, not its accuracy too. Whoever first chose 360 as the base for circular and astronomical measurement understood something fundamental about numbers and their relationships. Consider the precision required for these systems to work. The Sumerian astronomers could predict lunar eclipses using their base 60 calculations. The Egyptians could track the precession of the equinoxes, the slow wobble of Earth's axis that takes 26,000 years to complete a full cycle. The Maya could calculate when Venus would appear as a morning or evening star centuries in advance. This kind of predictive astronomy requires not just observation, but mathematical models sophisticated enough to account for complex gravitational interactions. These weren't primitive cultures making lucky guesses. These were civilizations with advanced mathematical frameworks. And here's the question that haunts this evidence. Where did they learn it? The standard answer is that they developed it independently through centuries of trial and error, observation and refinement. But the archaeological record doesn't support centuries of development. It supports sudden appearance. The mathematics shows up already sophisticated, already precise, already embedded in systems of measurement and timekeeping that would persist for thousands of years. That's not the signature of invention. That's the signature of transmission. Imagine you're a scribe in ancient Uruk, learning to calculate on clay tablets using the sexagesimal system. You're taught that 60 is the base, that the circle contains 360 degrees, that the sky can be measured in these units. But no one tells you why. No one explains who first chose 60, or why it's superior to 10 or 12. You're simply told, this is how it's done. This is the system. This is the knowledge passed down from the before time. You use the mathematics without understanding its origin. You calculate eclipses without knowing who first figured out the cycles. The knowledge works, so you preserve it, even though its source is lost in the mist of time that came before the flood. The mathematics remember what the civilizations forgot. Numbers don't drown. Calculations don't erode. Angular measurements and astronomical constants persist because they're based on physical reality, not human memory. When the cities sank and the libraries burned and the wise ones died, the mathematics survived in fragments, preserved by those who still needed to measure time, predict seasons and navigate by the stars. The survivors didn't understand why 60 was better than 10. They just knew it worked. They didn't know who first calculated the precession. They just knew the stars moved in predictable patterns. And they wrote it down over and over, generation after generation, until we found their tablets and realized we were looking at an inheritance from minds that understood the universe with a clarity that supposedly didn't exist yet. The numbers are a message in a bottle, thrown across the flood of time. And the message is simple. We were here. We calculated, we measured, we understood, and when we vanished, we left the mathematics behind, hoping someone would recognize the sophistication and realize we weren't primitive. We were your predecessors, and the knowledge you think you invented, we gave you. Stand in front of the Great Sphinx of Giza and look closely at its body. The limestone is weathered, deeply eroded, carved into vertical fissures that run down its flanks like ancient scars. For centuries, Egyptologists attributed this erosion to wind and sand, the relentless abrading forces of the desert. It made sense. The monument sits in one of the driest places on Earth, surrounded by sand dunes and exposed to harsh winds for millennia. The explanation was tidy, conventional, and completely wrong, because the weathering pattern on the Sphinx isn't consistent with wind erosion. It's consistent with water erosion. Prolonged, heavy rainfall. The kind of rainfall that hasn't occurred in the Giza Plateau for at least 7,000 years. In 1990, geologist Robert Schoch conducted a detailed analysis of the weathering patterns on the Sphinx and its enclosure. He compared the erosion profiles with known geological signatures of different weathering agents. Wind creates horizontal striations and undercuts rock formations from the base. Sand abrasion produces smooth, polished surfaces. Chemical weathering from groundwater creates different patterns entirely. What he found on the Sphinx was vertical channeling, deep undulating erosion, and rounded profiles characteristic of precipitation weathering. Water erosion, rain erosion, the kind that requires sustained periods of rainfall over thousands of years. The Sahara hasn't experienced that kind of climate in recorded history. But it did during the African humid period, which ended around 5,000 to 7,000 years ago, and was much more pronounced during the late Pleistocene, over 10,000 years ago. The conventional dating of the Sphinx places its construction around 4,500 years ago, during the reign of Pharaoh Khafra of the 4th dynasty. This dating is based primarily on stylistic analysis and proximity to Khafra's pyramid complex. But if the erosion is indeed from rainfall, and if that rainfall requires thousands of years of exposure, then the Sphinx must be significantly older than its attributed construction date. It must have been carved, or at least begun, during a time when the Egyptian climate was fundamentally different, a time when regular rains fell on what is now desert. A time before the accepted dawn of Egyptian civilization. The Egyptians themselves seemed aware of this discrepancy. The inventory stela, discovered at Giza in the 19th century, contains an inscription attributed to Pharaoh Khufu, builder of the Great Pyramid. The text describes Khufu ordering repairs to the Sphinx after it was damaged by lightning, not construction, repairs. The inscription explicitly states the Sphinx already existed when Khufu came to power, which would push its origin back even further into an era where, according to Orthodox history, the Egyptians were supposedly incapable of such monumental sculpture. Mainstream Egyptology dismisses the stela as a later forgery or religious fiction, but the physical evidence of water erosion doesn't require faith. It requires rain. Now shift your attention across the globe to Japan, to the waters off Yonaguni Island. In 1987, dive instructor Kihachiro Aratake discovered something on the seafloor that shouldn't exist. Massive stone structures with flat surfaces, right angles, and what appear to be carved steps, terraces, and geometric patterns. The formations sit at depths ranging from 15 to 100 feet below the surface, in an area that was above sea level during the last ice age when ocean levels were significantly lower. The structures include features that look disturbingly artificial. Straight edges meeting at precise 90-degree angles, parallel grooves cut into rock faces, and platform formations that suggest architectural intent. The controversy around Yonaguni centers on a single question: are these structures natural, geological formations shaped by tectonic activity and erosion, or are they remnants of human construction? Marine geologist Masaki Kimura has spent decades studying the site and argues for human involvement, pointing to specific features that seem inconsistent with natural fracturing patterns. The loop road, a pathway that appears to circle the main structure. The twin megaliths, two pillars standing side by side in ways that suggest placement rather than random breakage. The turtle formation, a rock carved into what looks like a recognizable shape. Critics argue that underwater rock formations can create unusual patterns through natural processes, and that humans are predisposed to see patterns where none exist. But the debate itself reveals something important. The site is anomalous enough that experts can't agree on its origin. Whether fully artificial or modified natural formations, the Yonaguni structures were above water during the last glacial maximum, roughly 18,000 to 12,000 years ago. Any human interaction with these formations would have occurred during that window, before the ice melted and the seas rose. If they are artificial or even partially modified by human hands, they represent construction or engineering during an era when conventional archaeology places humans in small hunter-gatherer bands with stone tools. The structures would predate Göbekli Tepe, predate Jericho, predate everything we consider the beginning of monumental architecture. Yonaguni isn't alone. Off the coast of Gujarat in India, in the Gulf of Cambay, sonar surveys have detected extensive geometric patterns on the seafloor, foundations that suggest urban planning, rectilinear structures, and artifacts recovered by dredging that include pottery, beads, and a piece of wood that carbon dating places at over 9,000 years old. The site is controversial, disputed, and difficult to access due to strong currents and poor visibility. But the sonar data shows something: structures, grids, patterns that suggest organization. Off the coast of Cuba, similar discoveries have been made: symmetrical stone formations at depths that would require them to have been constructed or submerged over 50,000 years ago based on sea level data, a timeline so radical that even alternative historians approach it cautiously. Off the coast of Malta, the temple complexes on land have apparent continuations underwater, submerged extensions that suggest the original structures were larger and more extensive before sea level rise truncated them. In the Caribbean, off Bimini, there are linear stone formations called the Bimini Road, rectangular blocks arranged in patterns that some researchers argue are too regular to be natural, though geological surveys suggest they could be beach rock formations. The pattern repeats: underwater anomalies that suggest human construction or modification in places that have been submerged for thousands of years. Some are clearly natural but unusual. Others are ambiguous. A few are disturbing in their apparent artificiality, and all of them share the same geological problem. They were above water only during a time when humans supposedly lacked the organization, technology, and motivation to build anything permanent. But the water erosion evidence isn't limited to submerged sites. In Lebanon, the megalithic complex at Baalbek contains foundation stones of such enormous size that modern engineers struggle to explain how they were quarried, transported, and placed. 3 of these stones, known as the trilithon, each weigh approximately 800 tons. They're fitted together with precision typically associated with much later Roman architecture, yet they form the foundation layer beneath Roman temples, suggesting they predate Roman construction. In the nearby quarry, there's an even larger stone called the Stone of the Pregnant Woman, weighing over 1,000 tons, apparently abandoned mid-extraction. The conventional timeline attributes these megalithic foundations to Roman engineering, but the Romans themselves attributed the stones to earlier builders, to giants or gods, suggesting they were already ancient when Rome arrived. In Peru, the fortress of Sacsayhuaman overlooks Cusco with walls constructed from blocks weighing up to 200 tons, fitted together with such precision that a knife blade cannot slide between them. The blocks have irregular shapes, yet they interlock perfectly, a technique that requires either extraordinary planning or extraordinary trial and error. The Spanish conquistadors who saw these walls attributed them to the Inca, but Inca oral traditions claim the walls were built by an earlier race of giants, by builders who came before. The weathering on the lowest, largest blocks is more pronounced than on the upper sections, suggesting greater age, exposure to different climate conditions, or both. These megalithic sites share common features: enormous stones, precision fitting, and construction techniques that seem unnecessarily sophisticated for their attributed time periods. And many of them show signs of water damage, erosion patterns, or weathering consistent with exposure to climate conditions different from the present. The stones remember the rain. They remember being carved when the world was wetter, when the coastlines were different, when the people who shaped them had time and resources and knowledge that the survivors would struggle to replicate. The monuments carved by water tell a story that geology confirms but history denies. They speak of construction during a climate that no longer exists, in places that are now underwater or in deserts that were once fertile. They speak of a world before the ice melted, before the floods came, before the coastlines changed. And they speak of builders who understood weight and stress and precision, who could quarry massive stones and move them and fit them together in ways that we still find challenging with modern equipment. The water carved its signature into these monuments, dating them not by inscriptions or pottery styles, but by the slow, patient work of erosion. And that signature says they're older, much older, old enough to have been built before the world drowned. There are over 200 flood myths in human culture, not flood stories, flood myths. The distinction matters because myths are supposed to be separate, independent creations, cultural responses to universal fears or local disasters. But when you line up these myths side by side, when you read them not as isolated folklore but as a collective testimony, the word myth begins to feel inadequate. Because these stories, separated by oceans and millennia, separated by language families that share no common root, separated by cultures that should have had no contact with each other, tell the same story. Not similar stories, the same story, with details so specific, so consistent, that calling them independent inventions requires ignoring the patterns screaming through the data. The Mesopotamian account is the oldest written version we have. The Epic of Gilgamesh contains the story of Utnapishtim, warned by the god Ea of an impending deluge that will destroy humanity. Utnapishtim builds a massive boat, seals it with pitch, loads it with animals and his family, and survives the flood that drowns the world. When the waters recede, he sends out birds to find land, first a dove, which returns finding nothing, then a swallow which also returns, finally a raven, which does not return, indicating land has emerged. The boat comes to rest on a mountain. Utnapishtim makes a sacrifice. The gods smell the sweet savour and regret their decision to destroy humanity. The parallels to the biblical Noah story are obvious, but the Gilgamesh account predates the biblical text by over 1,000 years. Both are drawing from an even older Sumerian source, the story of Ziusudra, preserved in fragmentary tablets that push the narrative back even further. The biblical account in Genesis provides familiar details. Noah warned of the flood, commanded to build an ark of specific dimensions, told to bring breeding pairs of animals, survives 40 days and 40 nights of rain, sends out birds to test for dry land, lands on Mount Ararat, offers sacrifice. The specifics vary slightly from the Mesopotamian versions, but the core narrative is identical. God or gods decide to destroy corrupt humanity with water. One righteous man is warned. He builds a vessel. He preserves life. The world drowns. He survives. Civilization begins again. This isn't vague similarity. This is narrative coherence across cultures. But the flood story doesn't stop in the Middle East. In India, the Matsya Purana tells of Manu, warned by a fish that grows to enormous size of a coming deluge that will destroy all life. Manu builds a boat, ties it to the fish's horn, and is towed through the floodwaters to safety on a mountain peak. When the waters subside, Manu becomes the progenitor of the new human race. The details shift. The divine messenger changes form, but the structure remains. Warning, boat, flood, mountain, survival, new beginning. The Hindu version is found in texts dating back over 2,000 years, but the oral tradition preserves it from much earlier. In Greece, the myth of Deucalion describes Zeus deciding to destroy humanity with a great flood because of their wickedness. Deucalion, warned by his father Prometheus, builds a chest, essentially a boat, and survives 9 days and nights of rain with his wife Pyrrha. They land on Mount Parnassus, make offerings to Zeus, and are instructed to throw stones over their shoulders, which become the new human race. Again, divine judgment, flood, survival, via boat, mountain landing, repopulation. The pattern holds. Cross the Pacific to the Americas, where the pattern repeats with disturbing fidelity. The Hopi of North America tell of the destruction of the Third World by water, with the righteous warned to climb into hollow reeds to survive. The Aztecs record that the fourth sun was destroyed by 52 years of rain, drowning the world, with survivors transforming into fish. The Inca preserve stories of a great flood sent by Viracocha to punish humanity, with one man and woman surviving on a floating box. The Mapuche of Chile describe 2 serpents causing the sea and sky to merge, flooding the earth, with survivors escaping to mountain peaks. The Maya Popol Vuh describes a great flood destroying the wooden people, the failed first creation, with survivors clinging to trees and rocks. In the Pacific Islands, separated from continental populations by vast ocean distances, the pattern persists. Hawaiian tradition tells of a great flood sent by Cain as punishment, with one man surviving to repopulate the islands. Polynesian myths across multiple island groups describe floods that destroyed previous worlds, with ancestors surviving by climbing to high places or sailing in canoes. Aboriginal Australians, separated from other human populations for over 40,000 years, preserve flood stories in their Dreamtime narratives, describing how the sea rose and drowned the coastal plains, forcing survivors to retreat inland. The African continent contributes its own flood narratives. The Yoruba of Nigeria tell of a deluge sent by the god Ifa, with humanity saved by climbing palm trees. The Maasai preserve accounts of waters rising to cover the earth, with ancestors surviving on mountain peaks. The Pygmy peoples describe a time when the rivers overflowed and the forest was submerged, with survivors floating on rafts or clinging to trees. Even in regions where flooding seems unlikely, the story persists. What makes these accounts more than mythology is their specificity. They don't just describe water, they describe specific types of catastrophe: prolonged rain, rising seas, rivers overflowing simultaneously, a combination of waters from above and below. They specify duration: 40 days and nights in biblical tradition, 9 days in Greek myth, 52 years in Aztec accounts, all numbers that suggest measured time rather than vague eternity. They describe survival methods: boats, rafts, hollow reeds, floating chests, all variations on the same solution to the same problem. They identify landing sites, mountains, high peaks, specific geographic locations that represent the highest ground available. They describe aftermath, sacrifice to appease the divine, repopulation from a remnant, the beginning of a new age. The conventional explanation for this global distribution of flood myths is that floods are common disasters, that river valleys flood regularly, that coastal communities experience tsunamis and storm surges, and that these local disasters become mythologized and exaggerated over generations. It's a reasonable explanation, but it doesn't account for the specificity of the shared details. It doesn't explain why cultures separated by oceans describe not just floods, but the flood, a singular event that destroyed the previous world. It doesn't explain why the narrative structure is so consistent: divine judgment, warning to one man, survival via boat, landing on mountain, new beginning. If these were independent responses to local flooding, we would expect more variation. We would expect different solutions. Some cultures building dikes, others moving to stilted houses, others simply accepting periodic flooding as part of life. We would expect different causes. Some attributing floods to angry river gods, others to seasonal rains, others to broken dams. But instead, we get the same cause: divine judgment against corrupt humanity. The same solution: a boat, the same outcome: near total destruction with a tiny remnant surviving. This isn't the pattern of independent invention. This is the pattern of inherited memory. Consider what it would take for a flood story to be preserved across 10,000 years. It would need to be important enough to repeat generation after generation. It would need to be traumatic enough that forgetting it felt dangerous. It would need to carry information survivors believed was essential for their descendants to know. The flood myths aren't entertainment. They're warnings. They say, this happened before, the world drowned, almost everyone died. We are the descendants of those who remembered to build boats, to seek high ground, to preserve what could be preserved. Don't forget, it could happen again. The myths also preserve details that only make sense in the context of a genuine catastrophe. The Mesopotamian accounts describe the flood as lasting 7 days and nights of intensity, followed by gradual recession. Geological evidence for the rapid sea level rise at the end of the Younger Dryas cold period, around 11,600 years ago, shows exactly this pattern. Abrupt melting of ice sheets causing rapid initial flooding, followed by continued but slower sea level rise over centuries. The myths describe birds being sent out to find land, a detail that only makes sense if the survivors were at sea for extended periods, long enough to lose sight of land, long enough that determining when to leave the boat required testing. The myths describe landing on mountains, which is exactly where you would expect survivors of coastal flooding to end up, on the high ground that remained above the new waterline. The global distribution of these myths suggests something that academic consensus struggles to accept: that the stories preserve actual memory of an actual event, passed down through enough generations that the memory became mythology, but not so many generations that the core details were lost. If a global or near-global catastrophic flooding event occurred at the end of the last ice age, drowning coastal settlements and forcing mass migration to higher ground, the survivors would tell their children what happened. Those children would tell their children. The story would spread with the refugees, carried to every continent by people fleeing the rising waters. And over thousands of years, the specific details would blur, the time frame would be forgotten. The cause would be attributed to gods rather than melting ice. But the core narrative would remain. The world flooded. Almost everyone died. We survived. Remember this. The flood myths aren't mythology. They're oral history, transmitted across a catastrophe so severe that it resets civilization, preserved in the only format that survives when cities drown and libraries burn: story. And the story they tell, in over 200 languages separated by geography and time but united by narrative, is that the world we inherited is not the first world. It's the world that came after the waters rose, after the cities drowned, after everything that came before was buried beneath the sea. The myths, remember. And they're telling us that the silence in the archaeological record isn't absence of civilization. It's the sound of civilization drowning. Agriculture appeared suddenly, not gradually, not experimentally, but suddenly. Around 10,000 years ago, in multiple locations across the planet, human societies transitioned from hunting and gathering to farming within what appears to be a remarkably compressed time frame. The conventional narrative describes this as the Neolithic Revolution, a slow awakening to the potential of domesticating plants and animals. But the archaeological evidence tells a different story. It tells of agricultural packages, complete systems of domesticated crops and animals appearing together, as if someone had already figured out which plants to cultivate, which animals to breed, and how to manage both for optimal yield. There was no 10,000-year learning curve. There was knowledge applied immediately and successfully. Consider wheat. Modern bread wheat, Triticum aestivum, is a hexaploid plant, meaning it has 6 sets of chromosomes instead of the usual 2. It's the result of at least 2 hybridization events between wild grasses that produced first emmer wheat, then later bread wheat. This doesn't happen naturally in the wild with any frequency. It requires human intervention, selection, and cultivation over many generations to stabilize the hybrid and make it viable. Yet the earliest evidence of wheat cultivation shows farmers already working with domesticated varieties that exhibit the characteristics of intentional breeding. Larger seeds, non-shattering seed heads that don't disperse naturally, and reduced genetic diversity indicating selection from a narrow gene pool. The archaeological sites don't show centuries of experimentation with wild grasses. They show domesticated wheat, already optimized for human agriculture. The same pattern appears with barley, which was domesticated around the same time. Wild barley has a brittle rachis, the part of the seed head that shatters when ripe, dispersing seeds naturally. Domesticated barley has a tough rachis that holds seeds in place, making harvesting efficient but preventing natural seed dispersal. This trait makes the plant completely dependent on humans for propagation. The mutation that causes tough rachis is known. It's a single gene. But selecting for it and stabilizing it in a population requires intentional cultivation over multiple generations. The earliest barley found in archaeological contexts already possesses this trait. The farmers weren't discovering domestication, they were implementing it. Move to the Americas where a similar pattern emerges with maize. Modern corn is so heavily modified from its wild ancestor, teosinte, that for decades botanists couldn't identify the relationship. Teosinte produces tiny seed heads with hard casings, protecting each kernel. Maize produces large cobs with hundreds of exposed kernels. The transformation requires multiple genetic changes affecting plant architecture, kernel development, and seed dispersal. Recent genetic studies suggest this transformation occurred relatively rapidly, possibly within a few thousand years, which is fast for such dramatic morphological changes. But what's more striking is that the earliest maize found in Mesoamerican sites already shows characteristics of advanced domestication. The Native American farmers weren't just starting to experiment with teosinte, they were cultivating recognizable maize. The domestication of animals follows the same compressed timeline. Dogs, sheep, goats, cattle, and pigs all appear in the archaeological record as domesticated species within a few thousand years of each other, clustered around the same period that agriculture emerges. Domestication is not simple. It requires selecting for specific behavioral traits, primarily docility and reduced flight response, over many generations. Wild animals don't become tame pets in a single lifetime. They become domesticated populations through sustained breeding programs that select for genetic changes affecting neurochemistry, stress response, and social behavior. The fact that multiple large mammal species were successfully domesticated within such a narrow time window suggests either extraordinary luck or existing knowledge about animal husbandry being applied systematically. The sophistication extends beyond simply growing crops and herding animals. early agricultural sites show evidence of crop rotation, irrigation systems, and storage facilities that suggest understanding of soil fertility, water management, and food preservation. At Çatalhöyük in Turkey, one of the oldest known agricultural settlements dating to around 9,000 years ago, excavations reveal granaries, evidence of organized food storage, and even proto-urban planning with houses built in dense clusters. This isn't a society figuring out farming. This is a society already competent in agricultural management. The metallurgical knowledge that appears in early civilizations presents similar anomalies. Copper smelting requires understanding that certain rocks, when heated to specific temperatures in controlled conditions, will release pure metal. This isn't obvious knowledge. Copper ore doesn't look particularly special. The temperatures required for smelting over 1,000 degrees Celsius are higher than normal cooking fires achieve. Someone had to discover that specific rocks, when subjected to specific processes, would transform into useful metal. And that knowledge appears suddenly in multiple locations: the Middle East, the Balkans, Southeast Asia, and the Andes, all developing copper metallurgy independently within a few thousand years of each other. Bronze metallurgy is even more sophisticated. Bronze is an alloy of copper and tin, and the optimal ratio is approximately 90% copper to 10% tin. Too much tin makes the metal brittle. Too little tin barely improves the properties of pure copper. The ancient bronze workers consistently hit the optimal ratio, suggesting they understood the metallurgical properties of different mixtures. But here's the problem: tin ore and copper ore are rarely found in the same location. Bronze production requires trade networks, resource management, and coordination between distant regions. The Bronze Age civilizations didn't gradually stumble into these trade networks. They established them rapidly and maintained them efficiently, as if long-distance trade was already a known concept being applied to new materials. Architectural knowledge presents the same pattern of sophisticated application without apparent learning period. Göbekli Tepe in Turkey, dated to approximately 11,600 years ago, features megalithic T-shaped pillars weighing up to 16 tons, carved with intricate reliefs of animals, arranged in circular enclosures, and erected by people who supposedly had not yet developed agriculture or settled communities. The conventional timeline places Göbekli Tepe at the transition between hunter-gatherer societies and agricultural societies. But hunter-gatherers, by definition, are mobile, small-group populations focused on immediate subsistence needs. They don't typically organize the labor required to quarry, transport, carve, and erect 16-ton pillars, unless they weren't typical hunter-gatherers. Unless they were something else, people with knowledge and organization that doesn't fit the expected profile. The architectural techniques themselves show sophistication. The pillars at Göbekli Tepe are carefully shaped, smoothed, and decorated. The enclosures show evidence of planning, with pillars positioned in specific arrangements that suggest astronomical or ceremonial significance. The labor coordination required to build these structures suggests social complexity, hierarchy, and sustained effort over multiple generations. This level of organization appearing 11,600 years ago, right at the end of the Younger Dryas Cold period, right at the time when global sea levels were rising rapidly, suggests that the builders brought their knowledge with them. They weren't inventing monumental architecture. They were implementing it in a new location, possibly after being displaced from somewhere else. The writing systems that emerge in Sumer, Egypt, China, and Mesoamerica show similar patterns of rapid sophistication. Early Sumerian cuneiform isn't crude pictographs slowly evolving toward abstract symbols. The earliest tablets show a system already capable of expressing complex ideas, recording administrative data, and preserving literature. The hieroglyphic system of Egypt appears fully formed during the First Dynasty, already capable of writing royal names, religious texts, and historical records. Chinese oracle bone script from the Shang dynasty shows systematic character construction with phonetic and semantic components already integrated. These writing systems don't show centuries of evolution from simple marking to complex notation. They show implementation of complete systems. What explains this pattern? Why does knowledge appear suddenly rather than gradually? The conventional answer is that the archaeological record is incomplete, that we are seeing the end result of long development periods that left no trace. But incompleteness doesn't explain consistency. It doesn't explain why agriculture, metallurgy, architecture, and writing all show the same pattern of sudden, sophisticated application. It doesn't explain why these knowledge systems appear in multiple locations within compressed time frames. It doesn't explain why early practitioners seem competent rather than experimental. The alternative explanation is transmission. The knowledge that appears suddenly in the early civilizations wasn't invented by them. It was inherited from predecessors who had already developed these technologies, already figured out which crops to cultivate, which metals to smelt, how to organize labor for monumental construction, how to encode language in written form. When the floods came, when the cities drowned, when the coastal civilizations collapsed, the survivors carried this knowledge inland. They couldn't preserve everything. They couldn't rebuild on the same scale. But they remembered enough. They remembered how to plant wheat, how to smelt copper, how to orient structures to celestial markers, how to organize symbols into writing. And they applied that knowledge as soon as they had stability, resources, and population to support it. The Neolithic revolution wasn't revolution, it was restoration. The knowledge that survived the flood wasn't invented in 10,000 years ago. It was salvaged from before, from the civilization that drowned, preserved in the memories of refugees who became the founders of what we call the first civilizations. They weren't starting from zero. They were starting from fragments, trying desperately to rebuild what had been lost, knowing that every generation that passed increased the risk of forgetting completely. The agricultural packages, the metallurgical techniques, the architectural sophistication, all of it appeared suddenly because it was being remembered, not discovered. And what we call the dawn of civilization was actually twilight. The last light of knowledge carried forward by those who survived the darkness of the flood. The ocean floor is not supposed to contain cities. It's supposed to contain sediment, geological formations, and the occasional shipwreck from recorded maritime history. But in the last few decades, as sonar technology has improved and underwater archaeology has become more systematic, something unexpected has emerged from the continental shelves. Structures, formations that look disturbingly artificial. Geometric patterns on the seafloor that suggest urban planning in places that have been underwater for 10,000 years or more. These discoveries exist in that uncomfortable space between confirmed and dismissed, documented but disputed, photographed but not fully excavated. They're evidence that refuses to fit comfortably into either natural geology or human construction. So they sit in academic limbo while the debate continues and the structures remain submerged, waiting. In 2001, the National Institute of Ocean Technology in India conducted routine sonar surveys in the Gulf of Khambat, formerly known as the Gulf of Cambay, off the coast of Gujarat. The sonar images revealed something unexpected at depths of 30 to 40 meters. Geometric patterns covering an area of approximately 9 kilometers long and 2 kilometers wide. The patterns showed straight lines, right angles, and rectangular formations arranged in grids. Follow-up surveys with side-scan sonar confirmed the presence of structures and recovered artifacts through dredging operations. Pottery shards, beads, pieces of worked wood, and what appeared to be construction materials. The artifacts were sent for analysis. The wood samples were carbon dated. The results came back with dates ranging from 7,000 to 9,500 years old, placing them in the early Holocene, thousands of years before the Indus Valley civilization that conventional history identifies as the region's first urban culture. The implications were staggering. If the dating was accurate and if the sonar patterns represented actual urban structures, then there was a maritime civilization in the Gulf of Kambat during the early Holocene, submerged when post-glacial sea level rise flooded the continental shelf. The site would predate Harappa and Mohenjo-Daro by thousands of years. It would represent urban planning at a time when humans were supposedly just beginning to experiment with agriculture. It would require a complete revision of the timeline for South Asian civilization. Naturally, controversy erupted. Critics questioned the dating methodology, suggested the artifacts could have washed down from later settlements, argued the sonar patterns might be natural, geological formations, and demanded more extensive excavation before any conclusions could be drawn. The site remains disputed, partially explored, and profoundly unsettling. The difficulty with underwater archaeology is that it's expensive, technically challenging, and often operating in conditions of poor visibility and strong currents that make detailed investigation nearly impossible. The Gulf of Kambat site sits in waters with visibility measured in centimeters due to high sediment load from river discharge. Direct observation of the structures is extremely difficult. Excavation would require massive resources and would disturb the site before comprehensive documentation could occur. So the structures remain documented by sonar, testified to by recovered artifacts, and disputed by those who find the implications unacceptable. But the sonar doesn't lie. Something is down there, something with geometry, something arranged in patterns that look intentional. Shift your attention to the Mediterranean, to the waters off the coast of Alexandria, Egypt. Underwater excavations have been ongoing for decades in the harbour, recovering artifacts and structures from the Ptolemaic and Roman periods. But in deeper waters, beyond the documented ancient harbour, there are anomalies. Sonar surveys have detected what appear to be structural remains at depths that place them before the current sea level, suggesting occupation or construction during periods of lower water. Stone blocks in arrangements that suggest foundations. Debris fields that look like collapsed structures. The Mediterranean basin has experienced complex sea level changes over the past 20,000 years, with different rates of rise in different periods. Any coastal settlement built during the lower sea levels of the late Pleistocene or early Holocene would now be underwater, preserved beneath sediment or degraded by millennia of wave action. In the Caribbean, off the western coast of Cuba, sonar surveys conducted in the early 2000s revealed extensive geometric formations at depths of 600 to 700 meters. The depth is problematic. At those depths, the structures would have been above water only during the depths of the last glacial maximum, around 20,000 years ago, when global sea levels were approximately 120 meters lower than present. The sonar images show what appear to be symmetrical stone structures, including pyramid-like formations and circular patterns, arranged in what looks like urban planning. The discovery was met with skepticism bordering on disbelief. Structures at that depth, with that apparent age, would require completely rewriting human prehistory. Follow-up investigations have been limited due to the extreme depth and the costs involved. The structures remain documented, disputed, and unexplained. Off the coast of Japan, beyond Yonaguni, there are other underwater anomalies that have received less attention, but present similar questions. Near Okinawa, divers have reported and photographed what appear to be carved stone features, including what looks like a face or carved relief, at depths that suggest submersion for thousands of years. The formations show straight edges, flat surfaces, and features that some researchers argue are inconsistent with natural weathering patterns. Critics argue that underwater rock formations can create unusual patterns through fracturing and erosion, that humans have a tendency to see faces and patterns where none exist, and that extraordinary claims require extraordinary evidence. But the features persist. They're measurable. They're photographed. They exist in locations that were above water during the last ice age. The coast of India's southern tip, near the city of Mahabalipuram, has long been associated with legends of 7 pagodas, temples that supposedly stood on the shore before being swallowed by the sea. Modern surveys have confirmed the presence of structural remains underwater, including what appear to be walls, foundations, and carved stones at various depths offshore. Some of these structures are clearly from the historical period, dated to around 1,000 to 1,500 years ago based on architectural style. But others, at greater depths and with more weathering, may be older. The tsunami of 2004 temporarily exposed some of these submerged features, with witnesses reporting seeing structures on the seafloor before the waters returned. The event sparked renewed interest in systematic underwater survey of the region. Off the coast of Taiwan, fishermen have long known about what they call the underwater city, formations that snag nets and show unusual geometric patterns. Sonar surveys have confirmed the presence of stone structures at depths consistent with submersion during post-glacial sea level rise. The formations include what appear to be walls, platforms, and aligned stones that suggest intentional placement. The site has received limited academic attention, remaining in the realm of local knowledge and occasional media reports rather than systematic archaeological investigation. But the formations are there, documented by bathymetric surveys waiting for resources and interest to converge for proper exploration. The pattern across these sites is consistent. Sonar or visual evidence of geometric patterns or structural features at depths that place them before or during the period of post-glacial sea level rise. Artifact recovery or visual inspection suggests human construction or modification. Academic controversy erupts around dating, interpretation, and the implications of accepting the evidence. Excavation is difficult, expensive, and often hampered by environmental conditions. The sites remain in limbo, neither fully accepted nor fully dismissed, documented but not integrated into the conventional narrative of human prehistory. But here's what's undeniable. Global sea level rose approximately 120 meters between 20,000 years ago and 6,000 years ago. That rise flooded millions of square kilometers of previously habitable coastal land. Any settlements, cities, or structures built on those coastal plains would now be underwater, buried under sediment, degraded by wave action, and difficult to access. The continental shelves were prime real estate during the Ice Age. Temperate climate, access to both marine and terrestrial resources, river valleys providing fresh water and fertile soil, coastal plains offering vast areas for settlement and agriculture. If a maritime civilization existed during the Ice Age, the continental shelves are exactly where we would expect to find evidence. And the continental shelves are exactly where we're finding anomalies. The cities beneath the waves, if they are cities, represent the smoking gun of pre-flood civilization. They're not artifacts that could have been moved by later cultures. They're not myths that could have been invented. They're structural evidence in locations that can only make sense if they were built before the floods. The fact that they exist in multiple locations across multiple continental shelves suggests this wasn't isolated settlement. This was widespread coastal occupation during a time when conventional archaeology places humans in small, mobile, hunter-gatherer groups. The sonar evidence, the artifacts, the geometric patterns all point to the same conclusion. Something was down there before it went down there. Something built, something organized. Something that understood urban planning well enough to arrange structures in grids, to orient buildings, to create the infrastructure of settled life. And then the waters rose, the settlements flooded, the inhabitants fled or drowned, and the cities remained, silent witnesses beneath the waves, waiting for technology to advance enough that we could finally see them and confront what they mean. Human DNA tells a story that history has forgotten. Written in the genetic code of every person alive today is evidence of a catastrophe so severe that it nearly erased our species. Population geneticists call it a bottleneck, a moment when the breeding population of Homo sapiens crashed to numbers so low that our genetic diversity was drastically reduced. The bottleneck isn't theoretical. It's measurable. When you compare human genetic diversity to that of other large mammal species, we're remarkably homogeneous. Chimpanzees, despite having far smaller total populations than humans, show significantly more genetic variation. This pattern indicates that at some point in our past, our population was reduced to a tiny remnant, and everyone alive today descends from that remnant. The genetic evidence places this bottleneck somewhere between 70,000 and 10,000 years ago, with some analyses suggesting multiple bottleneck events. The most recent and severe of these events aligns disturbingly well with the end of the last ice age. Around 12,800 years ago, Earth entered a period called the Younger Dryas, a sudden return to near-glacial conditions that interrupted the warming trend following the Ice Age. For approximately 1,200 years, temperatures plummeted, ice sheets that had been melting began to advance again, and climate became highly unstable. Then, around 11,600 years ago, the cold period ended abruptly. Temperatures spiked, ice sheets collapsed, sea levels rose rapidly. And something happened to human populations that left a genetic signature of severe stress. The bottleneck visible in our DNA intensifies around this period, suggesting population collapse coinciding with the catastrophic climate changes. This wasn't gradual adaptation. This was survival crisis. But humans weren't the only species affected. The late Pleistocene extinction event, which occurred between 50,000 and 10,000 years ago, with peak extinctions clustering around 11,000 to 10,000 years ago, wiped out approximately 80% of large mammal species across the Americas, 60% in Australia, and significant percentages in Europe and Asia. Mammoths, mastodons, giant ground sloths, saber-toothed cats, giant short-faced bears, woolly rhinoceros, giant beavers, glyptodons, and dozens of other megafauna species vanished within a geological instant. The timing of these extinctions correlates with human arrival in some regions, leading to the overkill hypothesis that human hunting drove the extinctions. But the overkill hypothesis struggles to explain why species that had survived millions of years of previous climate changes, previous human encounters in Africa and Eurasia, and previous periods of environmental stress all suddenly went extinct simultaneously across multiple continents. The alternative explanation involves catastrophe on a scale that affected the entire planet. Multiple lines of evidence point to extraterrestrial impact at the beginning of the Younger Dryas. Elevated levels of platinum, iridium, and other elements rare on Earth's surface but common in meteorites have been found in sediment layers dated to 12,800 years ago across North America, Europe, and Asia. Nanodiamonds, tiny crystalline structures that form under extreme pressure and temperature, appear in the same layer. Spherules, small glass-like beads formed from melted rock, thrown into the atmosphere and cooled in flight, are distributed globally in sediments from this period. Carbon spherules indicating widespread wildfires appear in the geological record. The evidence suggests either a direct impact or an airburst from a fragmenting comet or asteroid that triggered climate disruption, massive wildfires, and ecological collapse. The impact hypothesis explains several anomalies that climate change alone cannot. It explains the sudden onset of the Younger Dryas cold period, impact debris in the atmosphere blocking sunlight, triggering rapid cooling. It explains the extinction pattern. Large animals with longer generation times and lower reproductive rates unable to recover from the immediate devastation and subsequent climate instability. It explains the distribution of extinction across continents, a global catastrophe affecting ecosystems simultaneously rather than sequential regional collapses. And it explains the genetic bottleneck in humans. Population centers destroyed, food supplies disrupted, survivors scattered and isolated, breeding populations reduced to small, remnant groups. Now layer the agricultural revolution onto this timeline. Agriculture appears globally within 2,000 years after the end of the Younger Dryas, right when climate stabilizes following the catastrophe. The conventional explanation frames this as humans finally having stable enough conditions to develop farming. But the genetic evidence suggests something more urgent. Analysis of crop domestication shows signatures of severe genetic bottlenecks in the domesticated species themselves. Wheat, barley, rice, maize all show evidence of intense selection from small founding populations. This pattern is consistent with survivors of a catastrophe salvaging seeds from a limited gene pool, cultivating what they had, and rapidly expanding those crops out of necessity. It's not the signature of leisurely experimentation. It's the signature of emergency food production. The human genetic data reveals another layer of complexity. When population geneticists analyze the distribution of genetic markers across modern populations, they find evidence of ancient admixture, ghost populations whose genetic contribution appears in our DNA but who left no archaeological trace. These ghost populations show up in the genomes of modern humans as ancestral components that can't be attributed to any known ancient population. Some of these signatures suggest populations that existed before the bottleneck, populations that were genetically distinct from the surviving lineages, but contributed genetic material through interbreeding before they vanished. Where did these populations live? On coastlines that are now underwater, in regions that were devastated by climate change and impact effects, in the places where evidence of their existence would have been destroyed by the very catastrophe that may have killed them. Mitochondrial DNA, passed down through the maternal line, allows geneticists to trace human lineages back through time. The molecular clock, calculated from mutation rates, suggests that the most recent common female ancestor of all living humans, mitochondrial Eve, lived approximately 150,000 to 200,000 years ago. But the diversity of lineages beneath that ancestor shows significant reduction around 12,000 to 10,000 years ago, indicating that many maternal lineages went extinct during this period. The same pattern appears in Y chromosome DNA tracing paternal lineages. Multiple male lineages vanish from the genetic record during the late Pleistocene, suggesting that entire populations with their unique genetic signatures died out without contributing to modern humanity. The survivors, carrying a reduced subset of the original genetic diversity, became the ancestors of everyone alive today. This genetic pruning wasn't random. Analysis of the surviving lineages suggests that populations in certain regions had better survival rates. Populations in inland areas, away from coastlines that experienced rapid flooding. Populations at higher elevations, above the rising waterlines. Populations in regions that maintained ecological stability despite global climate chaos. The genetic geography of modern humans reflects this survival pattern, with greater diversity preserved in populations whose ancestors lived in areas that provided refuge during the catastrophe. Coastal populations, lowland populations, populations in ecologically vulnerable regions show genetic signatures of severe bottlenecking or complete replacement by inland migrants. The timing of major human migrations also clusters around this period. Genetic evidence shows significant population movements between 11,000 and 8,000 years ago. Into Europe from Anatolia, into India from both Western and Eastern sources, across the Pacific into previously uninhabited islands, into the Americas in waves that intensified during the early Holocene. These weren't exploratory migrations. These were refugee movements, populations displaced by rising seas, climate disruption, and ecological collapse seeking new territories where they could re-establish themselves. The genetic signatures show founder effects, small groups establishing new populations with reduced genetic diversity, exactly what you would expect from catastrophe survivors colonizing new lands. Domestic animals show parallel genetic histories. Dogs, the first domesticated animals, show evidence of domestication occurring between 15,000 and 30,000 years ago, based on genetic divergence from wolves. But the diversity of domestic dog lineages shows severe reduction around 11,000 to 10,000 years ago, with most modern dog breeds descending from a limited number of lineages that survived through this period. Cattle, sheep, goats, and pigs all show similar patterns. Domestication beginning before the Younger Dryas, severe genetic bottlenecks during or immediately after the event, and rapid expansion of surviving lineages in the early Holocene. The animals, like the humans, nearly went extinct and then recovered from remnant populations. The DNA doesn't lie. It preserves information across millennia with mechanical accuracy. And the information it preserves describes a species that came within a genetic whisper of extinction 12,000 years ago, that lost most of its megafauna companions, that survived in scattered refugia while coastlines drowned and climate destabilized, and that emerged from the catastrophe genetically impoverished, but carrying memories, skills, and knowledge salvaged from whatever came before. The genetic bottleneck visible in our chromosomes is the biological signature of the flood, the measurable consequence of the catastrophe that the myths describe. And the recovery pattern, the rapid expansion and diversification following the bottleneck, is consistent with survivors who knew what needed to be preserved, who had agricultural knowledge to implement, who had organizational skills to rebuild, because they were rebuilding, not building for the first time. The DNA of disruption carries the echo of the disaster, and that echo says we survived, barely, and everything that came after grew from the seeds, both literal and genetic, that the survivors carried forward from the world that drowned. Ancient art is filled with apocalypse, not metaphorical apocalypse, not symbolic destruction, but explicit depictions of catastrophe from the sky. Comets with long tails, fireballs descending, celestial bodies fragmenting, sky serpents devouring the sun. These images appear across cultures with disturbing consistency, carved into stone, painted on pottery, rendered in relief on temple walls. For centuries, archaeologists interpreted these images as mythology, as religious symbolism, as the poetic language of pre-scientific cultures trying to understand natural phenomena like eclipses and meteors. But when you examine the specificity of the depictions, when you analyze the astronomical accuracy embedded in supposedly symbolic art, the interpretation shifts. These aren't imaginative representations of celestial mythology. These are documentary records. These are warnings carved by people who witnessed something terrible and wanted their descendants to know it could happen again. The Lascaux cave paintings in France, dated to approximately 17,000 years ago, contain more than the famous animal depictions. On the ceiling of the shaft, there's a scene that has puzzled researchers for decades: a bird-headed human figure falling backward, a wounded bison with protruding entrails, a bird on a pole, and above it all, a series of dots arranged in patterns that some researchers have identified as star maps. The dots correspond to positions of bright stars and constellations visible in the Paleolithic sky. But there's something else in the arrangement, an anomaly, a bright object depicted where no bright star should be. Some astronomical archaeologists have proposed this represents a supernova or an unusually bright comet, events that would have been visible in the night sky and dramatic enough to warrant permanent recording. The association with the falling figure and the wounded animal suggests catastrophe, celestial and terrestrial linked. Move forward in time to the Sumerian cylinder seals, small carved stones that, when rolled across clay, create repeating images. Among the administrative and mythological scenes are depictions of celestial bodies arranged in ways that suggest not normal planetary positions but abnormal configurations. One seal shows a large celestial object surrounded by smaller objects, an arrangement some researchers interpret as a fragmenting comet or an asteroid with debris field. The Sumerians had sophisticated astronomical knowledge, tracking planets and stars with precision for calendrical and agricultural purposes. When they depicted unusual celestial configurations, they were documenting observations, not inventing decoration. The question becomes, what did they observe that warranted permanent recording in a medium meant to last? Egyptian tomb paintings and temple reliefs contain repeated imagery of the sky goddess Nut, swallowing the sun and giving birth to it each day, a poetic description of the day-night cycle. But there are variations on this theme that suggest something more violent. In some depictions, the sun disk is shown fragmenting, breaking apart, or accompanied by symbols of chaos and destruction. The pyramid texts among the oldest religious writings in the world contain passages describing the sky falling, stars descending, and fire raining from above. These texts were meant to protect the deceased pharaoh in the afterlife, but the protective spells invoke protection from specific threats: burning stones from the sky, celestial fire, the collapse of the heavenly vault. Why would the Egyptians need protection spells against falling stars unless falling stars were a recognized danger? The astronomical observatories built by ancient cultures reveal an obsession with tracking, not just the predictable movements of sun, moon, and planets, but also the unpredictable, comets, meteors, and near-Earth objects. Stonehenge in England, built in stages between 5,000 and 3,000 years ago, aligns with the summer solstice sunrise and winter solstice sunset. But it also contains alignments to lunar extremes, the northernmost and southernmost rising positions of the moon during its 18.6-year cycle. Why track lunar extremes? because doing so allows prediction of eclipses, and eclipses were events that needed to be anticipated. But Stonehenge's construction required hauling massive stones over enormous distances and erecting them with precision, an investment of labour that suggests the astronomical knowledge wasn't academic interest. It was practical necessity. The Mayan observatories tracked Venus with obsessive precision. The Dresden Codex, a Mayan manuscript surviving from the pre-Columbian era, contains detailed Venus tables calculating the planet's synodic period, the time between consecutive appearances as morning or evening star, with accuracy matching modern calculations. But Venus tracking served a specific purpose. Venus was associated with warfare, catastrophe, and the destruction of previous world ages. The Maya believed they lived in the fifth world, the fifth creation, with the previous four having been destroyed by cataclysms. Their astronomical observations weren't purely scientific. They were monitoring for signs of the next destruction. Their architecture encoded these concerns. The Temple of Kukulkan at Chichen Itza creates a serpent shadow during equinoxes, but the pyramid also contains astronomical alignments tracking Venus, the Pleiades, and other celestial markers associated with their catastrophe mythology. The Nazca lines in Peru, enormous geoglyphs visible only from the air, have been variously interpreted as astronomical calendar, water cult symbols, or messages to sky gods. But recent analysis of the alignments suggests they track solstices, equinoxes, and specific star rises that mark agricultural seasons. More intriguing are the geometric lines that point toward the horizon at angles that don't correspond to solar, lunar, or planetary events. Some researchers have proposed these lines track the rising and setting positions of particularly bright stars, or track the paths of meteors during regular meteor showers. The Nazca culture expended enormous effort creating markers that would last millennia, suggesting the astronomical information being encoded was considered crucial for future generations to preserve. Göbekli Tepe, the 11,600-year-old megalithic complex in Turkey, contains pillars carved with detailed reliefs of animals, foxes, snakes, scorpions, birds, and other creatures arranged in specific configurations. Analysis of the animal symbolism suggests they represent constellations, a star map carved in stone. But one pillar, Pillar 43, has sparked particular interest. The imagery includes a vulture, a scorpion, a circular object, and what appears to be a headless human. Some archaeoastronomers have proposed this pillar depicts a specific astronomical event, the position of constellations during the Younger Dryas impact event. The vulture corresponds to the constellation we now call Aquila, visible at a specific position in the sky around 12,800 years ago. The scorpion represents Scorpius. The circular object may represent the sun or a comet, and the headless figure may symbolize catastrophe, death, the end of an age. If this interpretation is correct, Pillar 43 is a memorial, a permanent record carved by survivors documenting the disaster that had just occurred. The Aboriginal Australians, custodians of the oldest continuous culture on Earth, preserve stories in their oral traditions that describe astronomical events with specificity that suggests eyewitness observation. Some Dreamtime stories describe a time when the moon came too close to Earth, when stars fell like rain, when the sky burned. These stories are accompanied by specific geographic details, locations where impacts occurred, craters that mark the places where sky stones struck the ground. Researchers investigating these oral traditions have located actual impact craters in the described locations, some dated to within the time frame suggested by the stories. The Aboriginal tradition of preserving knowledge through song, story, and landscape means information can persist for tens of thousands of years, passed down generation after generation with remarkable accuracy. When they say the sky fell, they're describing an event their ancestors witnessed. The warning encoded in all this imagery, all these observatories, all these careful astronomical records is consistent. The sky is dangerous. Catastrophe can come from above. Stars can fall, comets can fragment, fire can rain down. The cycles need to be watched because within the cycles are indicators of risk. The ancient astronomers weren't idle stargazers. They were threat analysts monitoring for signs of the next impact, the next climate disruption, the next catastrophe that could destroy civilization as their predecessors had been destroyed. And they encoded their warnings in the most permanent media they had: stone, star maps, monuments that would outlast the knowledge of why they were built. The urgency embedded in these warnings suggests the catastrophe wasn't ancient history to them. It was recent memory, living memory, transmitted from survivors to descendants with the explicit instruction, never forget. Watch the sky, track the cycles, know the signs. Because it happened before, it drowned the world, and it could happen again. The astronomical knowledge preserved in myths, monuments, and observatories isn't abstract. It's applied catastrophe prevention, the desperate attempt by a traumatized civilization to ensure their children would have warning if the sky betrayed them again. They couldn't prevent the next impact, but they could prepare. They could watch, they could remember, and they could carve that memory into stone, hoping that future generations would understand the message. The universe is not safe. Earth has been struck before, and the evidence of that strike is written in your DNA, your flood myths, your submerged cities, and your irrational fear of the sky falling. That fear isn't irrational, it's inherited memory. And the ancients left warnings everywhere in every medium that might survive, hoping someone would eventually decode them and realize the threat isn't mythology, it's astronomy. And it's still out there, orbiting, fragmenting, following trajectories that periodically intersect with Earth's path through space. Imagine the sea rises, not over centuries giving humanity time to adapt, but over decades. 50 meters, 100 meters, enough to swallow every coastal city on Earth. New York, London, Tokyo, Mumbai, Shanghai, Los Angeles, all submerged beneath the waves. Billions of people displaced, infrastructure destroyed, power grids failed, supply chains collapsed. Now wait 10,000 years. Let the sediment settle. Let the structures corrode. Let the ocean claim what we built. What would archaeologists of that distant future find when they survey the continental shelves? What evidence would prove we existed? What would survive to tell them we weren't primitive, that we understood mathematics and physics and engineering, that we built a global civilization? The answer is unsettling. Very little. And what did survive would be fragmented, disputed, and difficult to interpret. We would become the lost civilization, the mythological precursors, the anomalies that future scholars would struggle to explain. Start with our buildings. Modern construction relies on steel, concrete, and glass. Steel corrodes, especially in salt water. Concrete, subjected to centuries of wave action and chemical weathering, crumbles. Glass shatters and dissolves. The skyscrapers we consider permanent would last perhaps a few centuries underwater before collapsing into unrecognizable rubble. The Sydney Opera House, the Eiffel Tower, the Burj Khalifa, all would degrade into shapeless debris fields that future sonar surveys might detect as anomalies, but couldn't identify as intentional structures. only the largest, heaviest constructions might leave recognizable traces. Dams, perhaps, or the foundations of bridges, massive concrete pores that would take millennia to fully disintegrate. But these would appear as geometric anomalies disputed by scholars who would argue they could be natural formations, just as we dispute the underwater structures off Yonaguni and Gujarat. Our knowledge is even more vulnerable. We store information digitally, encoded in magnetic patterns on hard drives, electric charges in flash memory, optical pits on disks. All of it requires power, requires functioning technology to read. In a catastrophic scenario where infrastructure collapses, where power grids fail, where maintenance stops, our digital storage would survive weeks at best before degrading into unreadable noise. The internet, the collective knowledge of humanity accessible through smartphones and computers, would vanish the moment the servers went dark. Every digital photograph, every video, every document stored in the cloud would disappear as if it never existed. Future archaeologists would find blank hard drives, corroded circuit boards, and shattered screens. They would have no way to know what information we possessed, no way to access the accumulated knowledge of our civilization. We would appear technologically primitive, measured by what survives rather than what we achieved. Paper is more durable than digital media, but only barely. In optimal conditions, acid-free paper can last centuries. But submerged in water or exposed to humidity and temperature fluctuations, paper degrades within years. Books mold, ink bleeds, pages disintegrate into pulp. The Library of Congress, the British Library, every university archive, every bookstore, all would be reduced to organic sediment within decades of flooding. The printing presses that we consider revolutionary technology would appear as mechanical debris with no surviving examples of what they produced. Our literature, our accumulated written knowledge, all of it stored on materials designed for accessibility rather than longevity, would vanish. We would leave no tablets like the Sumerians, no stone inscriptions like the Egyptians, nothing that could withstand millennia of submersion and still communicate information to future investigators. Our art would fare slightly better, but only slightly. Bronze sculptures might survive, though heavily corroded and difficult to recognize as intentional art versus accidental metal formations. Stone sculptures would erode, losing detail but retaining basic forms. But the vast majority of our art, paintings on canvas, photographs, digital images, would disappear completely. The Mona Lisa would dissolve. The ceiling of the Sistine Chapel would flake away. Every photograph ever taken would fade or disintegrate. Future archaeologists might find fragments of statuary eroded beyond recognition and debate whether they represented artistic tradition or religious symbolism. They would have no context, no documentation, no way to know that we valued visual representation and preserved it in millions of forms that simply couldn't survive the disaster. What about our monuments, the structures we build to last? Mount Rushmore would erode, the carved faces losing definition over thousands of years of weathering until they became unrecognizable geological formations. The Hoover Dam might survive as a massive concrete structure blocking a river valley, but without documentation, how would future investigators know it was a dam? It would appear as an anomalous geological feature, possibly artificial, probably disputed. The Channel Tunnel connecting England and France would flood and collapse, leaving only the approaches as mysterious structures pointing toward the sea. The Great Wall of China, built of stone and brick, would fare better than modern constructions, but after 10,000 years of weathering, vegetation growth and geological processes, sections would crumble while others became integrated into the landscape. difficult to distinguish from natural ridge formations. Our monuments would survive as fragments, ambiguous enough that half the academic community would argue they were natural, while the other half insisted they showed signs of intelligent design. Our most lasting legacy would be the same as the legacy of the civilization that drowned before us: mathematics and astronomy. If any of our knowledge survived, it would be the fundamental constants, the relationships between numbers, the geometric ratios embedded in structures built large enough to resist complete degradation. Future investigators might discover that some of our surviving structures encode pi, that others align with celestial markers, that the proportions of certain foundations follow mathematical relationships. They would realize we understood geometry, that we tracked astronomical cycles, that we possessed sophisticated mathematical knowledge. But they would debate how we acquired that knowledge, whether we developed it independently or inherited it from even earlier precursors. The sophistication of our mathematics would seem anomalous for the technological level indicated by our corroded artifacts. We would become the mystery, the impossible civilization that appeared to understand physics and engineering at levels that their surviving artifacts couldn't support. The irony is profound. We are the civilization with the most advanced information technology in human history, capable of storing and transmitting knowledge at scales previous generations couldn't imagine. Yet we're also the civilization whose knowledge is most vulnerable to catastrophe. The Sumerians wrote in clay, which when baked or dried becomes nearly permanent. The Egyptians carved in stone, which erodes slowly over millennia, but leaves readable inscriptions for thousands of years. We write in bits and bytes, in magnetic orientations and electrical charges that require constant power and functional technology to access. Our knowledge is vast but fragile. Our monuments are impressive but temporary. Our information density is unprecedented, but so is our information vulnerability. If the catastrophe came tomorrow, if sea levels rose and cities flooded and infrastructure collapsed, the survivors would struggle to preserve knowledge. They would have no clay tablets to reference, no stone inscriptions to read. They would have smartphones that no longer work, computers that no longer boot, hard drives that contain petabytes of data locked behind encryption, and file formats that require specific software to decode. The survivors would remember. They would know what was lost, but they wouldn't be able to prove it. They would tell their children about the before time, about the cities that reached into the sky, about the network that connected the world, about the machines that could calculate and create and communicate. And their children would preserve those stories, passing them down generation after generation. Over time, the stories would become myths. The specifics would blur. The technologies would be described in metaphorical language because the technical terminology would lose meaning without the technology to reference. Future generations would tell stories of gods who could see across great distances, who could speak to people on the other side of the world, who built towers that touched the clouds. And scholars of that distant future would dismiss these stories as mythology, as primitive peoples trying to explain natural phenomena through supernatural narrative. We would become Atlantis. We would become the antediluvian civilization. We would become the lost ones that future alternative historians would argue about, while mainstream academics dismissed the claims as pseudoscience. The evidence of our existence would be fragmentary, corroded metal in strange configurations, concrete foundations that might be artificial or might be unusual geological formations, mathematical constants encoded in surviving structures, and myths passed down through cultures that all describe the same catastrophe, the same drowned world, the same lost knowledge. We would be the whisper that future civilizations hear when they excavate underwater sites and find anomalies they can't explain. We would be the pattern that suggests something came before, something sophisticated, something that understood mathematics and astronomy and engineering, but left so little physical evidence that proving its existence would require challenging the entire academic consensus. The lesson carved in stone by the civilization that drowned before us is the same lesson we're living now. Knowledge is fragile, civilization is temporary, and the confidence we have in our permanence is delusional. The pyramids still stand because they're built of stone and scaled to survive millennia. The tablets still speak because clay remembers what paper forgets. The flood myths still warn because story survives when books burn and servers crash and cities drown. If we want to leave evidence for civilizations that come after us, we need to think like the ancients. We need to carve in stone. We need to encode in geometry. We need to build structures so large and so precisely aligned that their purpose becomes self-evident across the gulf of time. Because if we don't, if we continue storing everything in media that requires power, technology and infrastructure to access, then we guarantee that when the next catastrophe comes, when the next flood rises, we will vanish as completely as the civilization before us vanished. And 10,000 years from now, future archaeologists will survey the continental shelves, find geometric anomalies on the seafloor, recover corroded artifacts that prove nothing, and debate whether we ever existed at all. The cycle will complete. The pattern will repeat. And the only difference between us and them will be that we had their example to learn from, and we chose not to.
If you enjoyed the video, hit the like button, subscribe, and activate notifications so you don't miss our next videos.